visible? Great, thank you. So let's start. Today's session is about software testing methodology. Let's start from the introduction of this session. So I got introduced as a QA, which is a quality analyst. So who is basically a QA and what is their responsibility? So a quality analyst is a person who makes sure whatever the product or the software which is given by a particular company is bug free and is very apt to the customer. So let's just say we have many apps today and we have many platforms, and each of that platform will have a quality analyst. So the main aim of this quality assurance is to make sure the customer have very good and nice experience. So the more customer experience and the more good the productivity will increase of that. So basically whenever you have something like not only in the domain of IT industry, let's just stay in the machinery industry as well. Like if you take a product, when it is getting manufacturing, there will be an analyst who makes sure the product is defect free. Any item you take, there will be a quality analysis on that item to make sure it is reaching defect free to the customer. Let's just say we have a random product. We have a bag which is manufactured at a company. So before reaching to the customer, it will go into multiple quality tests. Like if it is sturdy, it can put up on a weight, or it is it has no holes, etc., etc. The zips are working fine. So these are the process of a physical quality uh, engineering. So if you come into the software, we have certain testing methodologies which will help us define whether the software is defect free or not. So as a quality analyst, your job is to make sure the product is defect free and it has reliability and it comes in alignment with the customer experience. So yeah. So the testing methodology, here are the steps. First, we'll plan and then we'll design, execute, review, and optimize. So whenever you are given a product, you have to plan it. So for example, let's just take any e-com domain, like we have the popular Amazon. So before launching a product, they will give this analysis. Like let's say we have a new payment method which is going on Amazon. Like you all know, previously before this phone pay and all the payment methods, if you want to purchase anything online, you have to give your card number and card details, etc., etc., and then you have to place the order. But now with the UPI payments available, all you have to do is just enter a UPI ID. For that to be available on the screen, there is a couple of testings which should be done. So first is to plan, as in what should be tested, how should be tested, and how much time will it take for this particular software to be tested. And then designing. So designing is about creating test cases and test scripts. Like if you have a scenario, like just say you have a simple login page, you can write n cases of scenarios. Like I can give an ID but I cannot give a password, and if I give an ID but the password is wrong. So based on the scenario given to me, I can write n number of test cases and then test it. The main aim is to ensure that under no circumstances, the case should fail. Like the case should lead to the customer dissatisfaction. And then execution. So once you have planned and you have designed your scripts, you have all the test data ready, you have to execute it. Like we'll have this test environment similar to what we have in the um, customer endpoint. You'll have an background test environment where we'll run all the scenarios. Like I will be an actual customer in the test environment, and I will be giving a couple of details to that page. So that's how I execute it, and then review. So we'll document all this process. Like whenever we are doing the testing, there will be a documented process. Either it is through Confluence or it is through Word. We'll have all these documents will be available, and then we'll regroup again with the developers, customers, and then we'll go through a review. We'll give them that, see, we have tested so and so, and it is working fine. And then we'll go through it, and if we have to do any changes, if we have to change it, uh, or else if you want to add something, remove something, we'll have this review meeting, and then we'll go into the next step, optimize. So this is our first time experience. So coming forward for the new payments, like if you have Google Pay, you can use the same test scenarios, but you can remove the redundant scenarios you keep. Okay. And then these are the popular software testing methodology. First is the unit testing. The word unit suggests an individual component. So if it is a software, we have different components. We have UI, we have background, we have endpoint systems, we have API systems, we have connecting systems. So there are multiple systems, and unit testing is done in those particular system whenever we have to do a change. And then we move on to integration testing. The integration testing will integrate the components. Let's just say, let me explain this with an example. Okay, so we have, let me get back to the Amazon example. So Amazon, for you to place an order, you'll have the UI where you will get to display the products, everything. There will be a backend. There will be two developers, front-end developer, back-end developer. There will be a QA who is responsible for the testing. And there is an integration system, which is API, which is responsible between the connection between the front-end systems and the system. And there will be an order management system, which is responsible for your order number generation, etc., etc. And then these are the four components. First thing, whatever you see in the screen, that is UI. And then there is a backend, there is an OMS system, and then it is a maintenance or SAP system. Okay. Unit testing is done on individual level. The front end developer will design the UI. Like if you click on that payment method, whatever you see on the screen, that is front end. But when you click on that item, what will happen and how it is navigated to that page, that is backend. And when you click on confirm, there is a number generated, and that number will be your order number. And that particular number is sent to the downstream system where it will be sent to warehouse. Okay, so all your details under one order ID, it will be shared to the next system. And then the particular item which is mapped to the number is packed, and then it will reach to you. So unit testing, it will be done in individual level. Integration testing is something which is a combination or to make sure the communication between all these systems is working as expected. So then we come to systems testing or end-to-end testing. This is a testing which we will test from the start point to the end point. And then finally, acceptance testing. These testings will involve the business people for them to be an actual customer in our software, and then they will confirm if this is pleasing to the customer. Okay. And then black box testing, white box testing. So black box testing is basically done by the testers, and we don't know what exactly in the code. Okay, we just want the input and then output. You can take this classic login page example. I don't know how it is configured. I don't know whatever the code is written on the page. I just want to know if I give my email ID and password, I should be entered into my account. Okay. And my requirement to is to ensure whatever the customer gives in the two boxes, he should be able to go. And whatever which is not consistent with your account or some other to impersonate or a bot trying to reach out to into your account should not be successful. Okay. So I can test the n number of possibilities which are on that page. Like I have to test if I'm able to log into my account with my ID and password. This is happy scenario or happy path. Or we'll have a sad path or optimized path. Or we'll have some other path where it is not feasible for you to log into your account, like giving a wrong password. And if you think from a customer perspective, we have to check the negative flows as well. Like I will have to give the absolute nothing and then click on enter. But then I'll not be able to log into my account. That should be it. Or else we have to check some other flows, like we have some other flows like forget your password, try to log in with other Gmail, etc. So if it is available on the page, you have to check it. White box testing. White box testing is a set of testing which is done by the developer himself before giving it to the QA person. So white box testing, you will have the understanding or coding logic. Okay, this is to ensure that whatever you code, whatever you have in the page is working, like the link is visible. If you click on the link, it will highlight the URL. So something which is like, you don't know whether the URL is correct or not if you're a tester, but if you are a developer, you are the one who is putting the code there, so you'll have the understanding. So to put it in one point, black box testing is done by the testers and white box testing is done by developers. Next, smoke testing and sanity testing. So once all your testing is completed, you will do these two testings. One is sanity testing, other is smoke testing. Smoke testing is a very shallow testing. Like you can see the UI is constantly changes. Okay. So smoke testing is a testing which is done on a higher level. Like I change one component, I will test only that component, and whatever the other components which are already available is not my problem. Whereas sanity testing is that whenever you do some changes, when you do some build, okay, the existing functionality or the one which is already done previously should not change. Okay, so sanity testing is done as soon as the build is given by the developer. Like I did some change from a front end, I want the tester to do sanity testing. So if a tester does the sanity testing, the component is working fine, but the other component got affected by the change which is done by the developer. So in sanity testing, we'll be able to debug it, and then the build will be reverted back. Smoke testing is similar to sanity testing, but has a very low scope. Okay. Now come to manual testing and automation testing. So manual testing is something which is done manually. You can see it in your name. So if I do the testing, I log in as a customer, I take a screenshot, I document it. Okay, I'll give the password and ID. So that is a manual testing. Automation testing is done by using scripts. We have a couple of softwares, like we have IDE, we have Selenium, we have Cypress, we have Playwright. So all these softwares helps us to automate the testing scripts. What I'll do is using these scripts, I will give my ID and password or all the scenarios to the system. So it will open the system automatically. It will click the box, it will give the ID itself, and then in the background, it will record the session, and then it will give you the output. If it is not able to log in, it will load an error message and then copy it for you to review what is going wrong. Okay. So it's entirely automation process. So you don't have to do, all you have to do is write your scripts, give the credentials, system will take the rest of the testing for you. You don't have to put so much effort on this. Okay. And then different types of testing methodologies: waterfall testing and agile testing. So waterfall is a linear sequential process with the developmental phases. It's like a straight line. Okay, it's like I go to the customer, like I want to implement a new payment method. Okay, so let's just say I'm bringing Google Pay. So I, as a end user or a business person, I'll go into so and so company and I put an requirement saying that I want this payment method. Okay. And then there will be a discussion, there will be business analysts, there will be software architects. So they will have a call, and then they'll take this requirement. They'll create an user story for them. They'll do it on a high level. Once the understanding is done, they'll call the developers. Okay, developers, they will understand the requirement. They'll start coding. They'll put it into a form. And then once the development is done, they will give it to the QA person. They'll give it to the testers to test it, to test if the code doesn't have any bugs, the process is working fine. Since this is something related to the money, we have to make sure all the numbers are correct and all. So each and everything goes in a straight line or process. Okay, and everything is well documented. And this is a straight line, right? So if you have any requirements, you have to set it in the starting of the call, and then uh, the process will go on, and the endpoint will be the deployment. The Google Pay method is tested, verified, and given to the customers. Whereas agile testing, it's like complete iterative process. It's like a part of the, like today I'll generate the first page. I'll do some testing, I'll give it to the QA, and it will be tested. Or else I have a big plan where I have to do multiple payment methods. So I'll do the single payment today, other payment today. Like we have credit card, we have debit card, we have other options, right? So today I'll develop it for the credit card. Tomorrow I'll develop it for the debit card. Tomorrow some other payment method. So it's like an iterative process. If the customer wants some more experience or some more additions, feedbacks, he can tell it to the developers and they can include in the next sprint, and then they can do the changes. It's like an cyclic process instead of a straight line. So this agile testing is mostly used in the software because it's very flexible, and customer can increase or decrease the requirements, and then you'll have a faster delivery. Because see, if you see in the waterfall model, the tester is idle until the development is completed. Okay, so until the business requirement is given, the developers don't have anything to work on. It's like a linear process. So for the testers in this agile methodology, once the development of the piece is done, it will be going to the tester. So somebody has the work to do throughout the project. So that's why agile testing is more popular. And then we have functional testing and non-functional testing. Functional testing is like validating the feature against the requirements. So I have some requirements as a customer, and functional testing is to make sure that all the requirements are met. Okay, it's both common in waterfall and agile. It's like functional testing is like giving the correct ID and password to the login page and logging in. Non-functional testing is testing which will ensure the load, security, usability, and all. It's like functional testing is mostly on happy path and it's ensuring it's going in the correct path. But non-functional testing, it's like testing the page to the limit, ensuring there is no wrongs or issues. Okay. And then we came to the conclusion and takeaways. First, testing, enhancing quality. So the main task of the quality assurance engineer is to make sure we have defect free and satisfactory outcome to the customer. And then the second important thing is planning and priorities. So whenever you are working on something, there is a defect, there is a bug. So and then there might be some multiple bugs. So you have to understand which has more priority, which has more tendency, which has more effect, which is more critical. So that bugs you should prioritize first, and then you have to go into the low priority bugs or low priority work. Because as a QA, you should be responsible for the entire process, and you should have an understanding on the starting to beginning, and then you should be able to provide the feedback in each and every stage of the testing. Like let's just say unit testing, integration testing, system testing, and acceptance testing. QA is responsible to make sure that each and every phase of the testing, they'll have all the defect free and best working software. Okay. And then collaboration is very crucial. See, being a QA, you should have very good communication skills because you are interacting with multiple systems, and you should be top of everything. Like if you are in unit testing, you should know all the systems and all the individual change that is happening in the system. Because when you go into the integration testing, you should know what is coming from the source system and what is coming from the end system. So you have to interact with the source system people, and you have to interact with the end system. So sometimes being a QA, you have to get to interact with the client directly. So you should be able to understand it. And then continuous improvement. See, my favorite quote is like, there's always room for improvement. You might not be right all the time, but you can always learn from your mistakes. So if you can't put 100% on your first try on your first payment method, you can always learn from it, enhance your script, and get an updated script which can do the entire process in less time. You can always move on to that. Okay, so this is it. Thank you so much for your attention. I know